but the one thing I can tell you a little bit about, which Jim's going to tell you a lot about, is the quality of the minds of these young people that are coming up is absolutely incredible. Their DNA, they are makers. They are doers. And there's something that's going on, and it's reflected even in the Vintage Tomorrow's book that I was telling you about, that there's something broader going on in our culture. And Jim Ledger here, Jim's going to talk about sort of what's going on with the maker movement and how Intel's getting involved in it. Jim is in technical marketing, but for me, he's one of our main connections into the maker movement, not only because of his day job, because he also is raising an army of makers. I'm going to let him tell you all about that, but I think he's got he's helping not only Intel, but also the St. Ledger family to bring about an army of makers. So please welcome Jim St. Ledger.
Thanks, Brian. So my day job at Intel kind of looks like this slide. I work in what's called Communication Infrastructure Group, so that's all the gear behind the scenes that's connecting your phone to the internet and to other phones and things like that. So when you see me talk about that, I look like this. Today, I'm not going to look like that at all. I want to talk about something from my heart, which, as Brian mentioned, really isn't at all my day job, but something that I've been passionate about for probably more than 5 years, and has also had some interesting connections into my family, my personal life. It's been tremendously rewarding. I'm going to focus on kind of 3 areas today. I'm going to share with you my views on what I call the maker movement. How many people are familiar with the maker movement? When you hear that term, does it resonate at all? Maker movement, a couple of Intel phones. Okay, so I'll try to baseline people on that a little bit. I want to expose you to some of the areas where Intel is heavily involved in this maker movement, and I think that work very, very well complements what we're doing at places like ISEF and science fairs around the world. And lastly, I'll share with you some of those personal stories that are also woven into my presentation here. Hopefully I won't bore you too much.
Hey Jim.
Yes?
Can you just scoot back that way a little bit because the shadow otherwise cuts off the back, the bottom of your face. Yeah, that's better. That's better.
Is better?
Yeah.
Can you see me now?
Yeah, so we can't see your lovely face.
It's instead of can you hear me now, it's can you see me now?
Yeah.
Okay, thank you. You guys have come from a crowd like this, right? 1,600 students showcasing their brightest solutions, their research, their own passions in a somewhat structured, what I'll loosely call an academic environment. I spent a fair bit of time here at ASU, in the bioengineering labs and some other places here, Human Origins, and I see this quite a bit at a graduate level as well. And the poster sessions, the format always looks relatively the same. What's done behind the scenes varies by projects and passions, as Brian and Carlos and others have spoken about today. But there is a whole nother set of students. There's a set of students Carlos talked about that are behind the scenes in other places doing similar kind of work. And then there's an entire another wave of students that, for them, this is probably a little too structured, too formalized. They want to go do something, but they're more of the hands-on kids. When you tell them you need to write a hypothesis, come up with your test procedure, analyze it, draw conclusions, they probably check out at the first sentence. And these are the kids that things like shop class used to take care of. So when I was a kid in middle school, we had shop class. And shop class, at least in the States, involves going in and starting out to learn how to use hand tools and then power tools. You get to use a bandsaw, you get to use sanders, you get to actually make things. And it's a tremendously rewarding experience, especially for the students who may not be your A+ students and the guys that aren't kind of pre-programmed to do their homework, to take tests and do really well. The kids that do get really excited about shop class. The problem in the States with shop class is it's largely gone away. My son's middle school has no shop-related or making activities whatsoever. They have a computer lab where students go in and they learn the basics of PowerPoint. If they're lucky, they might learn how to create their own website, but that's about where it ends. At the high school level, they add a few classes in, but not very many. So this tends to be a big gap for students today. And while this has largely gone away, the interest in making things hasn't. This is the do-it-yourself movement. This still exists and has never gone away. And it's really seen a resurgence now for a couple of reasons I talk about. And this is fundamentally where the maker movement is starting, this resurgence of the do-it-yourself movement. It's people that may have college degrees in engineering, in science, in medicine, in philosophy, but when they go home at night, they like to tinker with things. They like to learn how to weld, so they go take a course at a local community college. They want to teach themselves electronics or computer programming, so they go online, they do a Khan Academy course or Coursera or something else. They teach themselves how to do other programming, how to build things, and they apply their hands and their minds to creating something. This is fundamentally what the catalyst of the maker movement today is all about. The other trends that are happening that are intersecting that are this movement towards open source. If you're at all involved in technology, you've heard of open source software, things like Linux, say open source Unix-like operating system. And there's many other elements of open source that my day job actually has me actively involved in. For those of you who don't know, Intel is extremely active in software, and that's fundamentally a huge part of my day job. But for the makerspace, it's not just open source software, it's also what's called open source hardware. And what that really equates to is to presenting projects, technologies, capabilities to people in an open source fashion. And that fundamentally is all about sharing. At ISEF, there'll be a lot of awards given out to the top projects. They'll all get ranked, and the top ones will get called out. In this domain, it's really about personal pride. One of the interesting things about makers is if given the choice between buying something at a store and making something themselves that actually costs them more to make, many times they will choose to make it themselves because they then learn something from it, have a personal sense of ownership to it, and can modify it and customize it along the way. And then what you also see is they will talk about it forever. So I didn't include a picture in here, but Brian talked about steampunk. There are some fabulous steampunk things out there. Some of my favorite are taking a basic old IBM click keyboard and making it look like it came from the Victorian era. It's again that meshing of today's technology with yesterday's historical elements of things. And it's just some fabulous activities. The other trends that are happening are things like Make Magazine. So Make Magazine has been out now for, it's probably 8, maybe approaching 10, probably 8 years, I don't know the exact date. And it's published by a company called Maker Media. And the CEO is a guy named Dale Doherty who's been tremendously passionate about this. He used to partner with Tim O'Reilly of O'Reilly Media on many projects for many, many years. But Dale and I actually talked, I appreciate his work tremendously, and he helped me with some of the content for my presentation, so thank you to Dale. But Make Magazine is really fundamental in helping these ideas scale out to a broader marketplace. It's available in print and a digital version, and what it really does is show people the potential of ideas. There's lots of projects in there. The projects include full detailed do-it-yourself instructions, so not only do they show you how to make a CO2-powered rocket and how cool it is, but they give you the instructions, and if there's elements, they say, here's where you go buy those. And then they go and create stores in other places where you can get hold of those. Now these projects, fundamentally, making is a hands-on activity. So it gets people back into tools. The first set of maker tools are the basic tools that I'd say most people have in a small toolbox in the garage. Right? It's a hammer, it's a screwdriver. You add some electronic components like a voltmeter and a soldering iron. And then as you get further into this, you start learning about electronics. And the board you see in the center is something that's really fundamentally accelerated the maker movement in the integration of physical instantiation and electronics and sensors and other things. And that's a board called Arduino. This grew out of a PhD project out of Italy through a gentleman named Massimo Banzi, I think it is, Skylar, right? And a few other students there, and it's just taken on a life of its own. And again, one of the fundamental things they've done with that board is they've created an integrated development environment for the software side of it that is completely open source. You take it, do anything you want with it, add to it, use it on your own, and an open source hardware design. So the exact design files, what are called Gerbers and schematics for this board, are available online. And if you could fab your own board and make your own boards or wanted to modify it, you're completely welcome to go do that. And it happens hundreds, if not thousands of times over, where somebody takes this design and says, wait a minute, I need a couple more I/O pins here, I need to add an extra interface here, etc. And it's really accelerated this do-it-yourself community of enabling people to do electronics for people that never thought they could ever do electronics and programming. So this is kind of fundamental toolkit of the maker community. And then it scaled up even more. And it scaled up more because commercial enterprises largely grew out of people's garages and passions. Companies like Adafruit Technology, a woman named Limor Fried, who was an MIT graduate, took her passion and turned it into a business. A person like Bree Pettis started a company called MakerBot with a few of his friends, took his passion for 3D printers and turned it into a business. And now these commercial companies are offering kits and components and ways for people all over the globe to get more immersed in this maker community. My son Skylar, who's sitting here in the middle, was doing a project or giving a presentation on Arduino, and we wanted to get a real-world data point on how reachable are these kind of components today. So when I was a kid, there was a company called Radio Shack, and we'd go into Radio Shack and they would sell you vacuum tubes and components and resistors, etc. Over the past 20, 30 plus years as I've grown up, they've gotten largely away from that business, and now they want to sell you cell phones and MP3 players and other electronic devices. But the last few years, they've seen the maker movement and they're getting back into it. So this was from, I think, last fall or last April when we popped into our local Radio Shack. And lo and behold, don't you see all these Arduino kits, doing your make your own robots and lots of other components in there. So this is 5 miles from my house, and Radio Shack is pervasive across the whole US. I can't speak to their global footprint, but now within reach of the vast majority of Americans are these maker electronic components. Again, accelerating the maker movement. I mentioned a few of these people. These are the faces behind some of those companies earlier. So Limor Fried on the left from Adafruit, Bree Pettis from MakerBot, Nathan Seidel from SparkFun, which is a company out of Colorado, right? What's really interesting about these companies, in addition to being a great source for makers for components and projects, they also really reach out and provide advice. Adafruit, Limor and Phil Terone host a engineer chat every Friday for 2 hours. You can go online and chat with them and ask them any question you want, and they're completely reachable. You know, find other companies in the corporate world where, you know, the top 2 executive officers are on an online chat with absolutely anybody for 2 hours a week. It doesn't happen, right? But this community is all about openness and engaging the audience and bringing them in. The other amazing thing, and this is also something you'll never see, is when SparkFun has a product, Adafruit might say, hey, can I carry that on my line as well? When Adafruit designs something, they may go share it with SparkFun. So they have this mutual competition and cooperation all at the same time. That's another thing about this community element that's very unique in the makerspace. By the way, this person at the bottom center is Jake Von Slack. He's kind of the maker's ultimate steampunk guy. And if you want to see some amazing, amazing creative projects, he again builds these amazing projects, goes to an incredible amount of detail to document every step, so you on your own can go and replicate it should you choose to do that. Again, the sharing element of the maker movement. Once people really start getting into this, of course, as you grow, your appetite for projects becomes bigger and bigger. And with bigger projects becomes bigger budgets and bigger tools and things like that. And this is where things like 3D printers and laser cutters and CNC routers come into terms. And this is where things like higher-end design software comes into the picture here. There's a company called Autodesk who's become extremely active in this space over the last 3 years or so. They're renowned in the commercial world for their top-notch engineering and design tools, such as Autodesk Inventor. They have some other tools that are used on commercial and municipal bases, on simulation tools, lots of other things. And then now we're saying, hey, you know, these people, these makers that are hobbyists, they can't afford to pay thousands of dollars for a license fee. So let's go create kind of a, let's call it the Bare Essentials tools and enable them for free. And they have things in this 123D design package like 123D Catch, which helps you do simple scanning with a tablet or a smartphone of items to do 3D modeling of it. And 123D Make that lets you take a design file and slice it up and build it in cardboard, then glue it together when you're done using cut it out of cardboard using a laser cutter, then glue it together and build all kinds of crazy designs. My son built a mallet that was about 4 feet long out of cardboard. It became a great prop for him. So, you know, lots and lots of tremendous excitement out here. The challenge on this is having enough money to buy all these tools, although the price points come down as competition in this market heats up. And this is where community organizations called maker spaces or hacker spaces come in. This is where common themed people, like-minded people that like to build things, sort of pool their money up and say, you know what, I'd love to have a laser cutter, but I can't afford the $3,000, $4,000, $5,000, $8,000 depending on how big of one I want. So if 20 of us get together and form a community group, we pool our money, we can all have access to the same tools. And these are known as hacker spaces or maker spaces, and they're all over the world. If you go to hackerspace.org, I believe it is, you can take a look and you'll likely see one in your country. I want to now transition a little bit from the maker movement of what it is and the tools they use into where you go and find these people. What do they look like when they come together? And one of the primary, I'll call it celebration events of it, is something called Maker Faire. And in fact, the key Maker Faire event, and the biggest one globally, is called Maker Faire Bay Area. It is this Saturday and Sunday in California in an area called San Mateo, between San Jose and San Francisco. And this event this weekend will attract over 100,000 people and hundreds of exhibitors. So you've got everybody from young children showing what they're doing to retired people showing what they're doing. It's just an absolutely amazing event, and if you ever have a chance to go to a Maker Faire, bring your friends and family, I guarantee you, you will have the time of your life. I've been going with my son for 3 or 4 years now, and last year we decided to take the entire family, thinking we weren't really sure how our younger kids, that were at the time were 6 and 8 years old, would like it. And they spent 2 full days there. On Saturday, I think they were there for about 14 hours and didn't want to go home. On Sunday, they came back till they closed the show, threw us out, and told us to go get on a plane home. So it's just an immersive, engaging experience when kids see the possibility of things they can do and see other kids doing it. This is the slide, again, Dale Doherty, thanks to him, shared with me, showing the growth of Maker Fairs. And there's a couple different types of Maker Fairs. There's one that the Maker Media folks put on themselves, and those biggest ones are the one this weekend in California, and there'll be one in mid-September in New York City called World Maker Faire. And those are just huge events. Like I mentioned, there'll be 100,000 people in California, and certainly north of 50,000 show up in New York City. And then there are other more regional events that you see up here that are in in red and green. Some of those are more localized events. There was one earlier, I think this year in Rome. There's several in the UK. I'll show you a map in a minute where they are. And then there's another model they have, which lets you go and replicate these fairs on your own. So this is a quick map showing you where in the world there have been Maker Fairs and will continue to be Maker Fairs. And how many people are from South America in here? I think there's a few from Brazil and Chile. I have to call out that there's a gap that there's been no Maker Fairs in Brazil. So I would like to challenge you to put together what's called a mini Maker Faire in Brazil. I don't know if you're from Sao Paulo or where.
Brazil.
Okay. It would just be fabulous to put it together. And the people at Maker Media actually have a complete guide that they've used year over year to fine-tune all the things you need to do to put on your own successful Maker Faire. And I'd love to talk to you after if you're interested in trying to do something like this, because I'm sure the Maker Media people will be really interested in a trip to Brazil as well to go and see the first mini Maker Faire in Brazil. It'd be a fabulous thing to do. But these events, some of them are run by Maker Media folks. Many, many more are run just by community leaders. Some are led by hackerspace groups. Others are led by community people that just are making things and they want to share their passions with others. And without exception, every time one gets put on, the organizers are always shocked by how many people show up to see it. Intel was involved in the first one in Oregon last year. Brad, I don't know if you went to that. I was told the reception of it there was just overwhelming, both in project ideas that people brought to it, as well as the community coming out to see it. So again, just fabulous community events. I have a couple pictures here to just give you a sense of what happens at Maker Faire. And again, it's everything from the smallest little electronic or robotics project to things as huge as building your own giant flame-throwing dragon. Right? Didn't everybody want one of these when you were a kid? And did you ever think you could grow up and actually make one? And then what's really cool about it, I don't know if you can see it in here, so over in the side here is where the controls are. And of course the flames are just a bunch of propane tanks with some actuators and relays and some spark igniters, etc. But you go over there and say to the guy, hey, can I shoot some flames? Yeah, come over here, push the button. And the people that make this are just so open to have you play with it and engage it, and then to tell you how they did it and their passions and why they did it. You know, Brian talked about inspirations and how so many of them are coming from fiction and science fiction. You know, these don't exist in real life. Well, yes, they do, right? This person undoubtedly had a passion for fire-breathing dragons as a kid, and eventually grew up to say, you know, I think I could make one of these, and wouldn't it be the coolest thing ever? And you see a lot of flaming devices, by the way, at Maker Faire. It's a big theme. They also bring a band that kind of blends technology and music together. It's called Architect. They're out of Austin, Texas, and they're a staple of Maker Faire Bay Area every year. They have a couple of very large Tesla coils that they built, and they tune and run it into MIDI files to become a musical instrument into their band. They also have a robotic drum section. It's just a bunch of servos and actuators, which seems trivial in comparison, but in itself is also a fabulous piece of music. And this is another huge event. When you see something that's shooting these giant bolts of electricity and also doing it to tune frequencies to play musical notes, I mean, it's just jam-packed, and just, you know, the students and the kids and the adults and everybody just get totally engaged with it. And then you can touch things yourself and get hands-on. And this is another favorite thing, right? Everybody looks for the kids with the longest hair to go over and put their hand on the Van de Graaff generator and see how big of a hair they can get. So these are just a couple of glimpses of some of the things you'll see at Maker Faire. Again, it's a fabulous event. I can't encourage you enough to reach out and go to one someday. Go to a local one, back where you're from, travel to one, come to New York City in the fall. We'd love to see you there. I'm going to transition a little bit now to Intel's involvement in these maker activities and Maker Faire specifically. And as with many things, including, I know we're coming up, I guess we're at the lunch hour here just about now, it all starts with the stomach. So the first thing Intel does is sponsor what's called the Maker Dinner. And of course, it's not your typical Maker Dinner. We have to have the giant paella guy show up with his 10-foot frying pan to make paella for several hundred makers, if not several thousand makers who show up for this. So we start there by sponsoring dinner, and then we work through to what really is the heart of a lot of our work at Intel and what Carlos lives every day, which is education, and specifically reaching out to middle school and high school students with initiatives like this. So on the Thursday before Maker Faire, so this will be happening tomorrow in the Bay Area, they have something called Education Day. And what they do is they get a bunch of the makers who are going to exhibit over the weekend to show up, and then they truck in as many students as they can from the entire Bay Area. And hundreds, I forget, I think it was thousands last year, Carlos, actually, 2,000 show up at it. And this year they're expecting even more, just to get exposed to this possibility. Because again, just like at ISEF, the kids don't know what they can do until someone shows it to them, and then they realize, wow, there really is nothing holding you back. Last year, our booth was something called Make Your World. And so what they did, again, to make it kind of student-friendly, they created a house that's kind of like a cartoon world. And the idea in the house was you walked in, you saw a variety of devices here that had all these little leads coming off of them. And the leads were looking for a switch that when you connected them together, activated some device. It could be a light, it could be a fan, it could be a tree that moved, whatever. And then the kids used foam core board, sticky foil tape, and made a very rudimentary switch. And so the kids were in there. Most of these kids don't understand even the basics of electronics. And as you're walking through this, you're talking about the concepts of circuits and things like that, but at a very simplistic level. So I happen to bring, these are my two youngest kids, I brought them along, and to be honest, neither one of them had done anything with electronics before, and they didn't know what the reaction would be. So they're in there, and they're playing with tape and stickers, and they're putting it together, and they really didn't know where this was going. But then when they got to plug it in, their faces lit up. And this is my son, who again was 6-year-old at the time. He went from, Dad, why are you taking me to this Intel Make Your Booth exhibit, to, do we really have to leave now? And he just totally embraced it. And he started figuring out every time he saw one of these spots that had leads come out of it, he would then look for, okay, what's this connected to, and what can I make happen by the little thing I just built? And it's the simplest device, but it empowers the kids so much that they leave very, very excited about what they just experienced. and now they want more. The other thing we brought there was something called the computer-controlled orchestra. This actually was an actual work-related project where we took a musical animation called Pipe Dream, and it was an animated video, and we actually built a physical system that replicated the animation in reality. And it used paintballs, you see these paintballs here, and it shot them at different musical instruments, the cymbals and top hats, and over here with a xylophone. And each one of these elements, they were just made of plastic, but they had sensors inside of it. And when the rubber ball hit the sensor, it activated a MIDI file that played that note, and the entire machine became a musical instrument. Again, this is a classic kind of maker device. Intel originally made this to prove out some of our embedded technology, but then we brought it to Maker Faire because this is where people just absolutely love seeing things like this. The other thing that I truly enjoy about working at Intel is the fact that while we all have day jobs, there's software engineers, marketing people, system architects, etc. There's a lot of people who like to go home and tinker and make things themselves. There's a big, big internal maker community at Intel. And we put out a call for makers when we were going to Maker Faire last year, and quite a few of them stepped up and said, hey, by the way, I'm working on something. So Mario, who works in Intel Labs in New Mexico, he'd actually built his own electric vehicle trike that he just cruises around where he lives. Josh Tannenbaum is one of the steampunk builders, and he builds his own goggles and devices and, you know, future laser shooters from the Victorian era of outer space, science fiction, etc. Another gentleman built a wind turbine based on components you can buy at your local hardware store. The items on the right were built by a guy named Jay Silver, and the top right one is something called Makey Makey. And this one probably wins the award for biggest smiling faces from kids. What Makey Makey allows you to do is you plug it into a USB port in your computer, and then you effectively tie some leads up to any conductive thing you want, and then you can use those elements as actuators. And in this case, what he did is he made a banana keyboard. So you could go up and by tapping on the bananas, play different musical notes. So if you've ever had a child that you've tried to get them to practice the piano like they're supposed to, you should see how quickly kids want to play this banana piano. It's just amazing. And if you're interested, go search on Makey Makey, M-A-K-E-Y, and you'll see other videos. He used this on a set of stairs where you run up and down the stairs and it plays different notes. So then you have to hop stairs to play and skip notes. And it's just one of these things that for a maker, it was a great fun project for him, that now he's out selling this as just a little commercial item that he just really enjoys, and so that everyone else who uses it. My son Skylar was also there. One of his passions is 3D printing. I'll talk more about it a little bit. And again, look at the faces on these girls. They were all just completely immersed in learning about what is this box and what does it do. And when they came there and they saw, okay, he's got this plastic stuff at the top that goes into some device here, and out of it comes some other devices. And he actually brought a couple of his 3D printed things. He can show you later on if you're interested. But the look on kids' faces of understanding how something gets made is just tremendously valuable. I think as we've lost touch with this concept of craft and making, we've lost an understanding of how and where things actually come from. Because the answer isn't, well, they come from the store. The answer is they get designed by someone and built in some factory building and then shipped to that store. There's this whole process behind the scenes, and the maker movement is really exposing that to people and letting them do it themselves. The other big activity Intel's doing in the maker movement area is something called Maker Education Initiative. Carlos is actually our representative on this group, and this got started last year as a joint activity between Maker Media, Intel, Cognizant, and Pixar. And Pixar you surely are familiar with from their animation feature movies. And these four companies got together and said, you know, we really need to formalize a program to bring these making concepts to students on a much broader scale. So they're doing a tremendous number of activities there. This summer, they're running what are called the Maker Cores. So it's similar to like the Peace Corps, but with a maker theme to it. They had a call for students earlier in the year, and I think there are 100 or several hundred that are going to go out this summer now. and engage students. Certainly, I think it's across the US right now, and then they have plans to try to scale that further after. From an Intel side, Carlos is also working with these kind of activities to go and run some of these concepts and ideas out through existing Intel programs, such as Intel Computer Clubhouses, that are reaching out to schools also. This year at Intel Maker Faire, you'll see us do this thing called Sketch It, Play It, where we're letting students build musical instruments using conductive paint. So they'll be able to go and paint things, connect them together in a similar fashion to what was done last year, but different, and then go create things that play notes and look like musical instruments. Again, something that the kids just view as fun, and then they figure out, hey, wait a minute, I just built that, and look what it does. And again, just immerse them in this possibility of what they could do here. One of the last things Intel's involved with, and this one kind of runs the bridge between our day business of selling the world's greatest processors and our passion in this room of educating people and embracing the maker movement. And that's something called the Minnow Board Project. It's an open source project that involves both hardware and software. The software side is through a Linux distribution called Yocto. You can look up Yocto project if you want more information there. And the Minnow board will be available just in a few weeks. It uses one of our Intel Atom processors to create a very high performance board for the maker movement. Today there are many boards such as Arduino that I talked about, which is a microcontroller. There is a higher performance solution called Raspberry Pi that moves you up to more capabilities and complexity. And then Minnow board is designed to take that up to yet another level. So this is a really exciting activity that we're doing. Again, you'll see these boards hit the market in a few weeks here, and we'll be doing more on this throughout the year. Okay, thanks for hanging in there with me. I want to move now and share with you a few more personal stories of how this whole maker movement and how I got immersed in it has kind of changed my personal life and my family. And as I mentioned earlier, how Make Magazine is accelerating things in the maker movement. This has been a pivotal moment in my own family. The issue on the left is one that a friend at work handed to my wife and I and said, I know your son and I really think he'll like this. At the time, we'd never heard of Make Magazine. We'd never heard of Arduino. I couldn't even have told you what the maker movement was at the time. But we brought this home, we handed it to our son, and I think for the next 10 hours we didn't hear a thing from him as he read it cover to cover. And then of course he comes out of his room and he says, Dad, I read this story about something called Garduino, which is creating your own electronically controlled garden irrigation system and lighting system using one of these Arduino controllers. And Dad, you need to order me the Arduino basic kit, the Getting Started with Arduino book, the extension Maker Electronics kit, and before we knew it, we had a $100 order going into Maker Shed for all these parts. And we thought, well, if he can teach himself some electronics, this is great. And by the way, my wife's an electrical engineer. She was also quite curious as to what was in this kit. But that's sort of what we call our catalyst moment where our son just took off down this path of electronics. And from there, frankly, there was no stopping it. He got a subscription to Make Magazine, was dismayed to learn it only comes out 4 times a year because he wanted to get this on. If he could, he'd get it on a weekly basis. We just started engaging these projects. And then the issue on the right shows up with Bree Pettis and his MakerBot Cupcake CNC 3D printer on it, which then ensued another discussion between the parents and child of, but I really need to have this, you just need to buy this for me. And after some negotiation on what it required to earn it, he did actually earn a Cupcake CNC 3D printer. And then he started to learn about 3D modeling. He learned about open source 3D CAD tools. He started drawing things, designing them, and printing them out. And this all led to him also joining a hackerspace. So as I mentioned earlier, a hackerspace is a community organization that's like-minded to try to build things, make things, and just have some fun, share their ideas. This group is in the Phoenix metro area, a location called Mesa, which is on the east side of town, or the East Valley. And the group is called Heatsink Labs. And these guys have just been tremendously welcoming to everybody. They've actually started a group called Young Makers, where they invite in students, typically ranging from, I'd say the low end is probably 7 years old, up to high school, and there's a lot of graduates, ASU students go there as well for access to the tools. And in their shop, they have several 3D printers, they have a laser cutter, I think they have 3 CNC machines, they probably have 20 Arduino boards of different varieties, and you name it, it's likely in there somewhere. And then when it comes to skill and expertise, you need to learn Python, you need to hit up on JavaScript, there's somebody in there who can help you. And they're willing and actually wanting to help you. So this was our kind of exposure to our first hackerspace here. What you see on the front here is also interesting to makerspace. So on the left is Skylar's Cupcake CNC. In the middle is what they call the FakerBot. So the files, I talked about open source hardware and software. One of the members took the open source files and actually built his own 3D printer. He used a laser cutter to cut the wood, ordered the parts, and put it together. And on the right is what's called a RepRap, which is a full open source 3D printer project. So it kind of runs the whole gamut of what's possible from a commercial perspective in a kit form to a pure open source hardware element. After this, my son Skylar got exposed to opportunities to share his information. And that turned into him wanting to engage opportunities. So there's a software developer conference that's done on a community basis called Desert Code Camp. And his first presentation was on Arduino to students his age. His next one was on 3D printing to adults, and these are all standing room only events. And his most recent one was on Arduino programming, again, to adults. And these kind of presentations have led to a lot of other people getting educated and pulled into the maker movement. And from there, it's also led to him doing other talks. He gave a talk on 3D printing at an event called Ignite Phoenix, which is similar to a TED Talk. And again, educated more people about what 3D printing is about. He was invited to an Autodesk event, Autodesk University, where he talked about his passion for making things. I joked with him that this was the only time he'll ever be on stage with Thomas Edison. And another talk he gave at Autodesk was about everyone being a designer. And they really wanted him to show their largely commercial audience of professional designers that, hey, these capabilities and knowledge points and interests scale all the way down to the youngest people. Therefore, everybody can do it, you should too. And it was another great event and opportunity. I want to close on a couple other proof points on what some other kids have done. The girl on the left, her name is Sylvia Todd. In the maker community, she's known as Super Awesome Sylvia. She runs her own maker show called the Super Awesome Sylvia Show. And she does it as a video chat that's recorded and then posted. And she just picks a project that she's interested in. She builds it and then shows you how to do it. And then she also says, hey, if you have a project idea you'd like to see me do, send it to me and I'll try to do it. Her latest project, in addition to many others that she's done, has been a watercolor robot. And you can see her demonstrating it here. This is a robot in here, and she actually has programmed it to paint a picture of the White House on a sheet of paper. Now think about what's involved in a project like this. So she has to understand electronics. She has to understand at least 2D modeling to be able to create the files that feed into it. She has to understand the translation from a 2D file into servomotor actuators and adding paint brushes into it to create color and many other elements. And this is something she just does because she really, really enjoys it. And again, you'll see her at Maker Faire. Another one is another student, Joey Hootie, who is also from the Phoenix metro area that Skylar is friends with. Joey was at the White House Science Fair last year. And I joke with Joey that he's one of the few people I know that got President Obama to actually do work for him. And so this was at the Science Fair last year, and Joey has a marshmallow cannon. And Obama said, well, let's see what it can do. So after they pumped it up with pressurized air, they actually were the only people to ever be allowed to shoot the cannon inside the White House. But if you look at the expression on the president's face, I think he was as surprised as the capability of this then 13-year-old kid as anybody was. Now, if you talk to Joey, to him it's just a, hey, I got exposed to this stuff 2 years ago. I built this with some PVC and an irrigation controller from Home Depot, and then from there he went on to become an expert in Arduino. Today Joey has, I believe, 3 Arduino kits that he's designed, prototyped, and built himself that he sells both on his own website and through Maker Shed. So you have this kid who's 14 years old now, who's been an inventor, an entrepreneur, and a businessman all rolled up into one. And he doesn't even know it, right? He's just doing this because he's absolutely passionate about it and he enjoys it. And if there's anything we all know about our careers is the more passion and joy you get from your career, the less it feels like a job, and the more it feels like, wow, they really pay me to do this. It's just amazing. So I want to summarize kind of my key 3 themes. The one is that the maker movement is gaining momentum, gaining steam. It's rolling out globally. It's a fabulous opportunity to give people back the opportunity to make things, an understanding of how to make things. It's a terrific complement to a lot of the educational activities out there today, from a standard public school education to science fairs and many other things that happen. These aren't conflicting things, these are opportunities for collaboration and complementing. And the last one really is, it's an innovation accelerator. It helps teach people how to build things, how to create things. You know, some of these can turn into patents, some of these can turn into just a project you have in your home, some of these can turn into full businesses. But this is really a fabulous, fabulous momentum opportunity building in the world, and I encourage you to be supportive of it, get to understand how it's being implemented locally, and perhaps start some maker opportunities for others in your area if they don't exist today. I believe you guys will get these presentations, so I put 2 reference pages in here. So if you wanted some more information, you can find out about Maker Fair events, the Maker Education Initiative that we're involved in, and Maker Education Day. There's also a book.
Can you go back one, please?
Sure.
Thank you.
One, two, three, done? Okay. There's also a book by a gentleman named Chris Anderson. In, I'll say, more business and academic circles, Chris Anderson is known for 2 things. Number 1 is writing the book called The Long Tail, and number 2 for being an editor and writer for Wired Magazine. Well, he's since left Wired Magazine because what most people didn't know is Chris had an absolute fundamental passion around drones. And he created a company called DIY Drones, or Do-It-Yourself Drones. And he's now left Wired Magazine to go and pursue that full time, and is off to an absolutely amazing start. Because he's enabling everybody now to go build their own drones. So you think about these giant, US military drones, well, think about ones that kids can make themselves for a few $100s. And if you want to see just some unbelievable creations and how quickly that's taken off, go take a look at DIY Drones and pick up a copy of Chris's book on Makers, The New Industrial Revolution. It's a great read. Lastly, because I am a proud father, I included some links to some of my son's talks in there. So these are all videos for the most part. If you want to learn about Arduino, you're like, Jim, I still have no idea what it is. My son Skylar, in about a 15-minute tutorial, will get you from knowing nothing to, wow, I actually could do that. And he does the same thing on 3D printers and then some of the other talks he's done. With that, I want to thank you for your time. I think we're getting closer to lunch, but I think there's one more quick talk in there. So thank you very much.